Hello, I'm Janet Silver from Syntax Strategic.
And I'm Cameron Groom from Microbics Biosystems. Thanks for joining us for Diagnostics Beyond the Lab. On this podcast, we talk to industry leaders in the scientific and health community about discoveries, challenges, and what they see as the way forward in their fields.
And Cameron, today we are going to talk about sample collection for infectious diseases, something we all came to experience firsthand over the last couple of years with PCR tests for COVID collected either through the nasal or throat swabs.
And in addition to that type of sample collection and testing, COVID also highlighted the importance of reliable sample stabilization and transport, ensuring test accuracy and maintaining reliable supply chains. Copan Group, based in Italy, is a leader in these fields. So joining us from Brescia, Italy, is Giorgio Triva, Strategic Project Manager of Copan. Benvenuto e grazie, Giorgio.
Thank you, Cameron.
Great. Well, Giorgio, Copan began over 40 years ago, and about 20 years ago, your family-owned company created the flock swab, which most of us have come to know as the swab put up our noses to test for COVID. Can you start by taking us back to how that idea came about?
Sure. Well, first of all, as you may know, Copan stands for Collection and Preservation for Analysis. So producing swab has always been our main core business and the main reason of existence for this company. So my father had invented the flock swab during a rainy day here in Brescia, while he was visiting one large market with my mother, and actually he noticed looking at some hangers, the tool used to keep jackets in the closets. He noticed some kind of velvet treatment on the external side of this tool, which is typically used to keep the jacket firm once they are hanged on these hangers. So looking at this treatment, he had this kind of epiphany where he got the idea of exploiting this treatment in the microbiological field in order to improve the way clinical swabs were manufactured, basically improving their performance of absorbing and releasing biological samples.
So with regards to the flock swab, Giorgio, when I look at it, it looks really very similar to a Q-tip, what people will use maybe to clean their ears or clean jewelry or what have you. How is it different than a Q-tip, the flock swab versus the Q-tip, and why could you not use a Q-tip for these kind of tests?
Well, for sure, they could look similar, even though we are talking about a medical device. So there's a bit of science behind that is maybe not clearly visible, but it's surely very important. So let's first start from the scope of a swab, which is basically to attract an analyte and more importantly, to be able to make this analyte available downwards for any kind of chemistry used to perform any diagnosis. So again, it could seem a simple object, but there's some kind of physical studies to make it in a way which is working well for the typical workflow used in clinical diagnostics. So the main reason why flock swabs anyhow are superior compared, for example, to other kind of traditional swabs or foam swabs is related to the way the fibers which are used to functionalize the swab are deposited on the stick used to basically as an holder to collect the sample. In this kind of treatment, which is the flocking technology we invented, we create a kind of microstructure of cells that are just the perfect way to guarantee a balance between the capacity of the system to absorb the sample, but not retaining it too much, and so being able to release it when needed for the chemistry used downwards, as I said before.
So a fast capillary-like uptake and a complete and fast release as well. So diving into that a little more deeply, Giorgio, precisely how much better is sampling with a Copan flock swab compared to a cotton swab, a Q-tip, or another spun fiber type swab?
Well, as I said, the swabs exists from quite a long time. So Copan was also and still is also a manufacturer of traditional bounded swabs. So we invented the flock swabs to improve what was our portfolio of products at that time. And from our studies that were very frequently done also thanks to the collaboration of the clinical community, we could notice basically an improvement of 4 folds in terms of the performance of releasing the analyte compared to, for example, the bounded swabs, which are very similar to the Q-tips, even more, let's say, and the foam or sponge swabs that you mentioned just few seconds ago. So basically, the importance of these performances that thanks to this improvement, we can reduce the chances of getting false negatives. And at the end, this is allowing to have a better diagnostics, which reflects in a better management of the cure for the patient.
Certainly, we've seen similar performance advantages in our own data, Giorgio, where variability of controls on a Copan swab is plus or minus 5% or in that order, compared to perhaps as much as plus or minus 100% variability on traditional swabs. So it's a real thing and a real advantage. How do you then ensure that each Copan flock swab performs consistently?
For sure, creating a company that is basing its success on this very tiny niche of the diagnostic field has been the first driver of the reason why we invested a lot in guaranteeing the quality of our product in the last 40 years. Quality clearly is not a negligible parameter, especially when dealing with medical devices that influence the quality of a therapy. So I like to say that, like Apple in the PC industry, Copan has always believed in the value of having a kind of end-to-end control of its processes. This means that starting from the very small plastic grain that we use to injection mold our sticks till the finished product is done. And thanks, obviously, to the hard work of very passionate team, we have been able to develop a lot of technologies that allow us to check efficiently and effectively the quality of each single product that is manufactured. More in particular, I would say that we exploit a lot of imaging technologies to detect even the smallest details that are not visible with the human eye, and our quality is then certified also by the recognition of our brand on the market, also in very challenging markets like for example the Japanese one, which is very very peculiar when it comes on measuring the quality of the product, also for very simple aesthetic defects.
Giorgio, we started off the podcast referencing COVID-19 and how we've all come to recognize the flock swab as something that we put up our nose to do those COVID tests. And I'm just wondering, are there other applications where flock swabs can be used in terms of sample collection?
Absolutely. Well, as the respiratory viruses are one family of reasons why people could be tested. Anyhow, you have to consider flock swabs and more generally the swab product family as a typically general purpose tool for non-invasive collections. To make some example, there are other applications where this approach is applied. You can think about HPV screening with vaginal samples, stool testing for, again, bacterial contamination or parasites, and many other cases where a simple and more practical tool of sampling is preferred over more invasive approaches. If you think also about how the scale of testing is growing over the last decades, it's clearly very important to keep the feasibility of these programs thanks to an easy way of collecting these samples. At the end, let's say simplicity is the ultimate sophistication, someone said.
Well, certainly we've seen the importance of flock swab technology through COVID, and getting better accuracy on testing has been incredibly important. But now that we've had that run through of the importance of proper sample collection technologies like flock swabs, Giorgio, what by extension would be your thought about the importance of some of the medium-based sample transport devices and practices? I'm thinking about some of the liquid medium that the swabs go into to stabilize them for testing.
Yes. So again, we are talking about large-scale testing, and this is typically requiring a high-throughput system, which means that very often samples need to be transported somewhere else to be tested, and very often to central laboratories that are taking care of these activities with an economy of scale, which is allowing them to make these analysis in a fast enough and economically viable way. So when you have to then transport the sample, the issue again comes with the integrity of it. So it's very clear that the importance not to waste this precious sample is on the ability to keep basically the target that you are searching for in a kind of a stable and stationary situation until the moment it reaches the testing center. And in order to do that, very often it's required the usage of particular mediums to guarantee these requirements are respected. So Copan has worked many years developing its own reagents and solutions to do that. UTM, which is the universal transport medium, was often used for COVID testing in the last 2 years. But we have also other types like INAT, for example, which is one of our solutions to basically immediately inactivate the sample at the point of collection, reducing the risk associated with the spreading dangerous pathogens during the supply chain or the logistic, or in a better way, and also giving the ability to have a safer management of these samples once they reach the testing laboratory.
Very good. And throughout the pandemic, we've seen that reliable access to pretty much any testing-related materials has been very difficult, especially with regards to high-quality materials. As a long-standing leader in the diagnostic field, particularly, of course, with sample collection and handling, what insights might you share on behalf of Copan about supply chains and how to ensure their integrity and security for infectious diseases testing?
Well, it has been surely an active period for all of us working in this field, considering that no one could, even though there were some kind of alerts from the scientific community and about the possibility of a pandemic sooner or later, it's also true that no one could predict precisely when it would appear. So Copan found itself as one of the few suppliers for these critical components, and we immediately reacted to the pandemic of the century, knowing the responsibility that we were having on our shoulders. And any component of the company have worked on a daily basis, remembering the importance of our work in order to let others to save lives. In the last 2 years, we have done our best to increase our manufacturing capacity, and we have opened actually 2 manufacturing facilities abroad in North America, in order to diversify the risk of the supply chain side, also shortening the distance from the end point of consumption for our product. Besides that, we have invested a lot to improve our capabilities in predicting the demand and trying also artificial intelligence technologies in order to read weak signals of the demand and activating then decisions faster than in the past. The basic anyway need for this supply chain optimization is anyhow the ability to keep data accessible to any of the player, any player who is working actively in the medical device industry, providing products that are used for epidemiological control, basically. So this was true surely during the COVID peak times, because we were reading journals and data about the testing capacities were available for almost anyone on the world. We should keep this approach, let's say, active, because this will surely help us and many other players in order also to detect, for example, a new potential emergency in the future.
It's amazing to see how much has changed over the past nearly 3 years now. Few people had heard, going back that far, of swab-based sample collection, viral transport medium, Copan, or for that matter, microbics. Now a lot of that's changed, but do you see us being prepared for another pandemic if we see a pandemic in 2024 or some point in the future? Are we prepared? And if so, why? And if not, why not?
Well, humbly, I cannot be the person who can answer on a global basis on this, but for sure we are more prepared compared pre-COVID. The whole industry have actually responsibly invested to scale up the production of basically everything that would be needed next time a new pandemic occurs. So anyhow, this strategy cannot, in my opinion, be left in the hand of the private sector only. These investments must be maintained somehow, and anyhow, some sort of continuous control in order to detect the weak signals I was mentioning before should be maintained in order to recognize if a new pandemic occurs. The complexity comes also from the fact that this is not an issue that one country alone could resolve. It requires basically a global intervention with a coordinated rules and flow of information that then reflects in the ability to react right in time to keep these risks under control. That's my opinion.
So, Giorgio, you're talking about preparations for a possible future pandemic, but I'm just wondering, looking back to what we've just gone through, are there lessons to be learned for policymakers, for those working in labs, laboratory directors, with what we've just gone through that we could implement now or should implement?
Well, for sure, talking about vaccines, they have contributed a lot in reducing strongly the risks associated with this specific pathogen. Let's not forget, anyhow, that testing is the only way to detect if a new emergency occurs. And again, having a more coordinated international action plan could be, in my opinion, a more useful way in exploiting the resources that are typically scarce, where and when they are more needed. Assisting again, for example, to a sort of, I don't know if this exists in English, caravan assault, with the objective to get hold of as many resources as possible could be maybe not the best way to mitigate the consequences, could be a good way to mitigate the consequences locally, but might not be the right answer to control an enemy who doesn't care basically of geopolitics borders. So in the next future, hopefully not so next, my hope is that truly policymakers will find a way to create more synergies in this case, because again, if you have a surge in let's say in a positive rate in a specific region, stockpiles 1,000 kilometers far away from there are maybe not so relevant in order to again control that risk. And if that risk spreads, then we are not probably optimizing the resources at their best.
So some of that capacity that's been built up, for example, coming out of COVID, how do you think we should be deploying that over the next decade or couple of decades? Is that in biovigilance for new pathogens? Is that for better healthcare more generally? Are there any specific areas that Copan has identified that those resources should be allocated toward?
Okay, so difficult answer, but I don't expect to have a crystal ball here. I would say from our side, being a pre-analytical company, we are here to serve basically any need that could emerge and any use case that could be useful for the management of these risks on a community basis. My personal dream would be to see like a kind of an higher degree of decentralization of diagnostic tools, not necessarily in opposition with the current centralized infrastructures, but maybe opening the door to new use cases that today we as a society are not able to target or to detect. So this scenario would surely require safe, simple, and economically viable technological tools. But if, again, we make a comparison to what happened in the personal computer industry, comparing how mainframes were used before, I kind of feel a positive thrill for what could come next in the microbiological field.
Are you thinking about self-collection and point-of-care testing, Giorgio?
Absolutely, for sure. Bringing potential positive contaminated individuals to a single point to get them tested might not be at the end the best way to control this kind of risks. At the same time, we have clearly to manage a regulated market with needs of certifying the validity of this product and the validity of the results that these diagnostic tools can give. So it's not an easy answer, but the humanity have been able to reinvent itself many times and creating fantastic inventions. So I don't want to limit our fantasy here in imagining how in the next pandemic we will react. At the end, the objective, in my opinion, should be potentially not to generate a new pandemic. So being able to detect it fast enough in order to, let's say, to limit the spread in a way in which basically we avoid it. But again, even if this is not possible, having the ability to test people in a decentralized manner is for sure interesting as a let's say technological infrastructure where to develop new use cases. At the moment, I don't have one. Otherwise, I would surely propose it. But I believe there are potential opportunities there to improve the way we know our communities, and we know the leverages we can play to at the end provide to these communities a better way of living.
Well, Giorgio, will be watching to see if those global synergies actually come to fruition. Giorgio Triva from Copan, based in Brescia, Italy, thank you so much for joining us.
Thank you so much.
Thank you so much, Giorgio. Privileged to be working with you and the Copan team on helping to realize some of these ideas and opportunities. That's all the time we have for today, though, so thank you again, Giorgio, and thank you for tuning in, everyone. I'm Cameron Groom.
And I'm Janet Silver, and this is Diagnostics Beyond the Lab. Till next time.